This video presents an effective approach to trophectoderm biopsy for blastocysts at different stages and characteristics using the mechanical blunt dissection by Professor Lee's group. A blastocyst biopsy is performed to obtain a reliable genetic diagnosis during in vitro fertilization cycles with pre-implantation genetic testing. To date, there are few systematic video tutorials on trophectoderm biopsy for blastocysts of different stages and characteristics, especially using the mechanical blunt dissection method. Here, we summarize a set of effective approaches to the trophectoderm biopsy for different characteristics of blastocysts by mechanical blunt dissection. And now we will demonstrate the proven and safe method for trophectoderm biopsy performed on various blastocysts. First, an artificial shrinkage of the blastocyst is induced by applying one laser pulse at the junction between trophectoderm cells, providing a safe distance from the inner cell mass. Generally, the blastocyst will collapse after artificial shrinkage. The blastocyst is positioned by the holding pipette. A hole is made by a laser pulse in the zona pellucida away from the trophectoderm cells and inner cell mass. The biopsy pipette is carefully priced against the opening. 5 to 10 cells are aspirated into the biopsy pipette with gentle suction. The biopsy pipette is moved away from the blastocyst. Stretch the selected fragment and expose the junctions between the cells. After 3 laser pulses, the holding pipette is maneuvered to the rim of the biopsy pipette. Detach the biopsy by a mechanical blunt dissection. Subsequently, the biopsy fragment is released. If the blastocyst is not collapsed after artificial shrinkage, then the first step is to make a hole in the zona pellucida. The subsequent gentle expulsion of the medium from the hole will separate the trophectoderm cells from the zona pellucida. The next biopsy is the same as the collapsed blastocyst after artificial shrinkage. For peanut-shaped hatching blastocysts, part of the blastocyst is herniated through the zona pellucida. Our approach could provide better control over the aspiration of trophectoderm cells into the biopsy pipette. First, the laser pulse is aimed at the herniation of the trophectoderm cells from the zona pellucida to make it collapse. Then the holding pipette is positioned perpendicularly to the axis of the herniation of the trophectoderm. After reducing the trophectoderm herniation, the steps of the trophectoderm biopsy are the same as the fully expanded blastocyst. The biopsy of the 8-shaped hatching blastocyst is relatively simple. The embryo is secured by the holding pipette at the opposite side of the herniation of the trophectoderm cells, and the subsequent steps of the trophectoderm biopsy are the same as the fully expanded blastocyst. Importantly, if the inner cell mass is herniating from the zona pellucida, the biopsy method remains the same as for a fully expanded blastocyst, but the trophectoderm biopsy should be performed away from the inner cell mass. In the last part, the biopsy method for hatched blastocyst is demonstrated. It is worthy to note that the mechanical blunt dissection works best for a fully hatched blastocyst. The embryo is secured by holding the pipette, which should be away from inner cell mass. The trophectoderm opposite to the inner cell mass is brought into the fine biopsy pipette, and the subsequent steps of the trophectoderm biopsy are the same as the fully expanded blastocyst. Notably, biopsy pipettes with 20 micrometer outer diameter can effectively control the target number of trophectoderm cells, making the biopsy of fully hatched blastocysts easier. Similarly, there are other suitable mechanical shearing methods that can be tried, such as tapping on the biopsy pipette holder with a pen or finger. Our biopsy strategy does not involve assisted hatching on day 3 or day 4 embryos, which can leave the embryo undisturbed in culture orb to the expanded blastocyst stage. The mechanical blunt dissection method may reduce thermal damage because fewer laser pulses are used, compared to the traditional laser-only biopsy techniques. For the non-collapsed blastocysts, the strategy of the expelling medium helps the trophectoderm separate from the zona pellucida, facilitating the biopsy. For the peanut-shaped blastocysts, this approach could provide better control over the aspiration of trophectoderm cells into the biopsy pipette, especially if the inner cell mass is herniating from the zona pellucida. The trophectoderm biopsy can be performed away from the inner cell mass to avoid damaging it. The mechanical blunt dissection approach, combined with the biopsy pipette of 20 micrometer outer diameter, can control the target number of the trophectoderm cells effectively, making the biopsy of the hatched blastocysts easier. That would be all. Thank you.